Hey everyone, welcome back to DevOps with Umesh channel. Today I will explain what is AWS Load Balancer is, why we use it, and which type to choose in real architectures. So this is the load balancers. So think it like a traffic police officer that sends cars to the least crowded roads. So load balancer is automatically distribute incoming web traffic to the multiple servers. So here our server is EC2 instance, EC2 1 2 3. So if the traffic is high, then incoming traffic automatically distributed to the multiple servers. The main goal is the high availability, fault tolerance, and scalability. Next slide. So this is the simple visualizations where this is the users, this is the load balancer which actively uh, checking the health checks, and it routes the traffic. So here we can see that this is the fail instance due to the traffic routed unhealthy detected, and the incoming traffic from users goes into EC2 2 and EC2 3. So we can see that this is the simple visualization of the load balancer. So if my app, so it basically like if our app is run on 3 EC2 instance and 10,000 users hit it on then the load balancers distribute those traffic to the single EC2 instance. If we have 2 EC2 instance and the 10,000 users hit it, then it distribute this traffic. And because of if we have only one EC2 instance, it get overloaded and it got infested. That's why the load balancer comes in pictures. So this is the next slide. Why we use a load balancer? Because to avoid the single point of failure, we need to avoid the single point of failure, improve performance, and handle the traffic spikes and perform the health checks. We can see that this is the fail state and this is the active. The traffic goes in the active state. So this traffic is automatically routed away from the fail instances. So traffic is not goes inside of the failed instance, it goes in active instance. So yeah, so this is the key advantages: automatical scales, integrate with auto scaling. This is the manage the OS fetching, high availability, monitoring. We can monitoring our applications with this. So what is elastic load balancing? It's a fully managed service by AWS. So it automatically handles the heavy lifting of load balancing. So you don't have to install, configure, and maintain the load balancer servers yourself. So don't need to do anything. If we attach the ALB, that is elastic load balancing, then it will manage automatically. So that's why it is a managed service. On next slide, so there are 4 types of AWS load balancer: application load balancer, network load balancer, classic load balancer, and gateway load balancer. This is the 3 are in main purpose. This is the old generation's load balancer. This is not is used nowadays. This is the 3 application load balancer, network load balancer, and gateway load balancer are used. So yeah, these are the type. So we can see that application load balancers is used for web routing. Network load balancer is used for high speed network traffic. Classic load balancer is for legacy, And gateway load balancer is basically used for security appliances. So in the depth, we can see that application load balancers. So the application load balancers work at layer 7 at HTTP and HTTPS. So it understands the URL and can route based on the path. It's great for web apps and microservices. So it's can route based on the path. So there is based on the login API. So that's why that is for smart routing. It's used for microservices. So yeah, that's it. So the example are request to login can go to the auth service, and request to the login go to the auth service, and request to the API can be the backend service, that is the path routing. So next one is network load balancer. So network load balancer works at layer 4. So it's I think it's mainly used for the low latency. So it's ultra low latency, used for ultra low latency, can handle the millions of requests. We can see that it's handle the millions of requests based for high performance workloads. If so, for example, if I am handling the real time gaming traffic, and this can be handled through the network load balancer. So yeah, this is the terminologies that we see here. That is use the TCP. What is TCP? It's the transmission control protocol. You can um, look the slides. So what is that transmission control protocol? So it is basically connection oriented and it's reliable. So it's ensured that the data arrives correctly. That's why websites and files downloaded commonly using the transmission control protocol. That's why. So it's basically TCP is basically like a phone call. So it's if a connection is established and or if we connect it to the call, connection is established and receiver receive that calls at it's so it's basically the client server act as a client server. So client is basically send the information and server is getting it. That's why we can understand as the transmission control protocol. Next one is UDP, is user datagram protocol. So it's basically a connection. It's basically connection, and it's like sending protocols in the fast way. But it does not ensure that each protocols arrives to the receiver, because sometimes some postcards are in the dropping state. We can see that it's something you can see in the right is dropping state. So yeah, is the communication protocol that sends the data packets without establishing a formal connection. Yeah, so these are the key characteristics, that is connectionless and faster but unreliable. So yeah, that's why we can understand the user datagram protocol. The next type of load balancer is classic load balancer. So classic load balancer is the old generation load balancer. It supports the HTTP and TCP, but AWS generally does not recommend it for the new applications. So if the company has the legacy setup created 2 or 3 years ago, then they might still be on the classic load balancer. If the company is new and the application we created as a newly, then we don't want to use the classic load balance nowadays. For the new design, we typically choose application load balancer or network load balancer. So that's when you can understand it. So next type is gateway load balancer. So gateway load balancer is work at layer 3, right? So it's used to deploy the security appliances like firewall, IDC, IPS. So yeah, so IPS is basically centralized traffic inspections. If our organizations wants all inbound and outbound traffic to pass through a firewall appliance, then it helps to scale and manage that using the gateway load balancer. So yeah, that's why we can understand this. It's mainly used for the security appliances. Then we can see the differences of this is the main difference that mostly asked in the interview. That is the application load balancer and network load. What is the difference between this? So you can say that application load balancer works at 7 layer and network load balancer works at layer 4. It has a smart routing. It has the ultra performance is highly million of requests are accepted in millions of seconds. It's and rich features is a low latency, so best for real time and high throughputs for the gaming purpose, and best for web applications and microservices. So that's why we can explain the differences. Yeah, this is the real time example of the architectures. So here is the users, that is the web traffic incoming from the application load balancer. That is our application load balancer. And the traffic goes distributed, because here we have EC2 instance, that is auto scaling group. What is the auto scaling group? We have the 3 group. If our load is increases, then it adding the extra group in our auto scaling group, because if we can say that EC2 instance A and B are there, but if load our CPU is greater than 70%, then one instance of that group is added. So we can say that C instance is initializing means creating. That's why you can understand that. So in the real architecture, so if so during the peak hours, right, auto scalings add more residents, that application load balancer starts sending traffic to the new instances, right, automatically once they pass the health check. All right, yeah, that's it. So we can understand that by using this architecture. It will be simple one. And then next slides is for interview uh tips and mapping. So yeah, so usually the first decision is I am routing the HTTPS request intentionally. Then yeah, we can say that if yes is an application load balancer. If it's a fraud TCP and UDP use performance, then we can use the network load balancers for the smart routing, application load balancer. For the old networks, the application is created before 2 years or 3 years ago, then we can use the classic load balancers, and for the security we can use the firewall. So that's why we can recall it. So yeah, also this is also the small cheat sheets, that is HTTPS is used for the application load balancer, million something requests are coming in per second. Then network load balancer, the classic EC2 means old generations application are created before 2 or 3 years. Then classic load balancer, and the security appliances we can use the gateway load balancer. That's it. These are the mostly slide of application load balancer. Thank you for watching, and best luck for the interview. If this question is asked in AWS DevOps Engineer interview or DevOps Engineer interview, yeah, and please subscribe the DevOps with Umesh channel. If you like it, these slides, then like. If you want to share, please share it. And if you want anything I talk the wrong, then it's please comment it, and if you like it, then also please comment it. If you want to improve my anything I want to improve here, then you can comment below. Yeah, good luck for your cloud journey. Yeah, that's it. This is the main video of AWS load balancers. Yeah, so that's it. Yeah, thank you for watching. Bye.